If China wants more factories, warehouses, and transport systems to run with fewer mistakes, then planning becomes a practical question, not a lab curiosity. A robot does not just need to see boxes, tools, or coordinates. It needs to decide what to do next, and then keep deciding over many steps. That matters now because China is investing heavily in industrial automation and embodied AI. In that setting, failure is expensive. A system that misreads space, forgets a rule, or cannot adapt to a changed layout can slow the whole operation. New research from MIT speaks directly to that problem. It asks whether AI systems that understand images can be paired with older planning software that is more strict and reliable. The result is not a finished answer, but it helps explain a real bottleneck in the kind of automation China wants to scale. The MIT system combines two different strengths. First, a vision language model looks at an image, describes the scene, and simulates possible actions. The researchers call this smaller model SimVLM. Then a larger model, called GenVLM, takes that description and turns it into files written in a formal planning language called PDL. Those files can then be fed into a classical planning solver, which computes a step-by-step plan. After that, the system checks whether the solver's result matches the simulation and keeps refining the plan files. In simple terms, one AI model tries to understand what is in front of it. Another translates that understanding into a format a more rigid planner can use. This matters because image-based AI is flexible, but often sloppy over long sequences. Formal planning is less flexible, but much better at rules, structure, and longer eyes and asks. Vision language models are good at recognizing objects and producing fluent descriptions, but the MIT article points to two weaknesses that matter in the real world. One is spatial reasoning. These models can struggle to track where things are in relation to each other. The other is long-range reasoning. They may produce sensible first steps, then drift off course. That is a serious problem for tasks like multi-robot assembly, navigation, or autonomous driving. In these settings, one wrong assumption can break the entire sequence. The classical planners have the opposite profile. They are strong at multi-step reasoning, but they cannot directly rate images and usually need experts to encode the problem by hand. The MIT approach tries to bridge that gap. For China, that is relevant because scaling robotics is not just about better models. It is also about building systems that fail less often in messy, changing environments. The reported gains are notable, but they need careful reading. The article says the two-step system generated plans with an average success rate of about 70%, compared with roughly 30% for the best baseline methods. It also says the broader framework reached about 60% success on 6D planning tasks and more than 80% onto 3D tasks, including multi-robot collaboration and robotic assembly. The simulator component describes scenes, simulated actions, and detected goal completion in about 85% of experiments. These are strong signs of progress, not proof that the problem is solved. The work still relies on bounded test settings, and the researchers themselves say there is a long way to go, especially on more complex scenarios and hallucinations. So the key point is modest but important. Hybrid systems may outperform pure visual AI on planning tasks, especially when rules and reliability matter. The larger China question is not whether one MIT paper changes the field. It is what kind of AI stack will matter most in a country trying to deploy automation at scale. China has strong incentives to use AI in ports, warehouses, i.e. factories, and urban mobility. In all those places, systems must handle visual input, shifting conditions, and clear operational rules. That makes this hybrid logic interesting. It suggests the next gains may come not from asking one giant model to do everything, but from linking perception models to specialized tools that can reason more reliably. That is a useful lens for watching China's AI race. The contest is not only about model size or flashy demos. It is also about whether systems can turn seeing into dependable action. This research does not answer that fully, but it does sharpen the question, and that already makes it worth watching.